Welcome to the session of bending stress and shear stress. Here we are discussing shear stress distribution across the section. Content, moment of inertia of some standard section, shear stress distribution diagram, and shear stress on rectangular section. Here we are discussing moment of inertia of rectangle, hollow rectangle, circle, and hollow circle. For rectangle of side B and D, moment of inertia about x-axis is BD cube divided by 12. For hollow rectangle, it is capital BD cube minus small bd cube divided by 12. For circular section of diameter d, I is pi by 64 into d raised to 4. And for hollow circular section, I about x-axis is pi by 64 into capital D raised to 4 minus small d raised to 4. Let us move for shear stress distribution diagram. Here I have rectangle and circle. This is the neutral axis. This line represents zero shear stress. This line represents the outermost layer of rectangle and circle. As we can observe, tau value is 0 at the outermost layer. As we are moving from outermost layer to the neutral axis, tau increases layer by layer. So the shear stress distribution is parabolic in nature. Maximum shear stress at the neutral axis and zero shear stress at outermost layer. Let us go for some combined section, that is I and hollow rectangular section. This is neutral axis. This line represents the zero shear stress. These are the two extreme lines which represents the outermost layer. Here tau value is 0 at the outermost layer. As I and hollow rectangular section is a combination of different parts. Here is a node number 1. As we are moving from outermost layer to the neutral axis, shear stress increases layer by layer. Shear stress at node 1 is tau 1, which is parabolic in nature. As we are moving from node 1 to node 2, observe this carefully. We have abrupt change in the width. So shear stress increasing drastically, which is linear in manner. So tau 2. Moving from node 2 to node 3, shear stress increases layer by layer. So that is represented by means of parabolic curve. Tau 1, tau 2, tau 3 are the values of shear stress for node 1, node 2 and node 3 above the neutral axis. Similar values we are getting below the neutral axis also, which is parabolic in nature. Excellent. We have learned the shear stress distribution diagram for rectangle, circle, I section and hollow rectangular section. Let us move for the numerical based on rectangular section. Here cross section of rectangular section is given, that is 100 into 200 mm. Shear force of 50 kilonewton is acting on this. And we have to sketch the shear stress distribution diagram across the rectangular section. In order to sketch the shear stress distribution across rectangular section, it is necessary to determine the value of shear stress with this equation. So tau is equal to SAY upon IB. So S is given, that is 50 kilonewton. Area of section we can calculate, that is P into D, 100 into 200. So 20 into 10 raised to power 3 mm square is the area of rectangular section. Similarly, the value of D, which is given here, that is 200 divided by 2, that is 100 mm. Here I about x-axis is BD cube divided by 12. If I put the value of B 100 and D 200 cube, I get Ix is 66.6 into 10 raised to power 6 mm raised to 4. Let us move for Iyy, that is dB cube divided by 12. So I get Iyy is 16.6 into 10 raised to power 6 mm raised to 4. So let us put the values of SAY and IB in the equation. Little bit problem about I. So we have to select the I from these two. Here I am selecting Ixx, that is 66.6 into 10 raised to power 6 mm raised to 4 because it is maximum in magnitude. If I do the calculation, I get tau is equal to 15 Newton per mm square. Excellent. So here we have learned moment of inertia of some standard section, shear stress distribution diagram, which is a key part, and a numerical based on rectangular section. Thank you.